Okay, we're off and running. So good evening, welcome. This is the night before Thanksgiving, so hope. Let me first start off by saying that I hope you have a great break, rest, enjoy your time with friends, family, and do take a break from the class too. It is important to do that for sure. You'll see me over here. You might see my dog jump on the screen. But also, we're starting to look ahead. We're in the final tonight, and then we're going to have our 4 days next week, and that's going to be it for instruction. So, what I'll probably do is over the break, probably weekendish, I'll create some reviews just to kind of help you with the sort of problems that you can imagine or imagine that you might see on the final exam, and I'll probably even go ahead and create the final exams just to kind of get ahead of the curve. But then too, to help guide a review on that. So that's coming over the days here to kind of give you some idea as to what you can anticipate the types of questions. It will be cumulative, but I hope that doesn't cause any consternation because as you can sort of see from the last 3-4 weeks, everything we do is sort of cumulative. You got to keep drawing back from the first half of the class with a lot of things. So you know, um, you have a lot of skills already mastered. Probably what's more needs to be mastered is and really more what we need to review and focus our review on is the stuff from the second half of the class. And that's probably what I have in mind. Okay, so I got this question here from a student, and I appreciate. Let me say thank you for sending your questions because they really do help me to know what we need to review, what we need to discuss further. So keep them coming. Don't hesitate here. Okay, so the question, and
Wait,
let me see.
real
Let me
quick.
check with you first. Can you see the screen? You see two graphs here. A screenshot of two graphs. Okay, good. Okay, so what we have here is let me first start off here. Let me first make clear of what I'm seeing because it looks like two different things. Hold on just a second. Okay, so I zoomed it bigger so that we could see what was I struggling with here. This thing here, this thing here, that's the composition operation. The open circle, that's the composition operation. Uh, uh, I was getting it confused with a different operation. So you'll see an open circles there. So this says f composed with g, and f is the first function, so it's the outer function, and g is the second function, so it's the inner function. And let me go ahead and zoom back out. Sorry about that. Let me do this. Oops. Okay, there we go. Back to it. Okay, so f composed with g means f of g of -2. Okay, so remember our process is we work inside out, and we have to find the output of the inside function because the output of the inside function becomes the input of the outside function. Find the output of the inside becomes the input of the outside. So with that in mind, we're going to do f last. But what we do is we replace the inside with the output of g of -2. So what's the output of g of -2? Okay, so we have to go to the graphs now to help us understand. And one thing too that I probably didn't make clear when we were going through it the first time is that the graphs are the outputs of the function. Remember, they represent the y values. So the graph is the output, is the ultimate thing. So how are we going to do the inside part of g of -2? How are we going to do the inside part of g of -2? Well, you got to look, what do we have? This red line over here, or now I'm coloring it blue, that's the g function. And this other line over here is the f function, okay? So just to kind of differentiate between the two. So this one says we do g of -2. So take -2 and input it into the g function. So -2, remember, that's an x. That's the x. So go to the x-axis, go to the x-axis here and find the value of -2 on that x-axis. Okay? So where is it? Well, here it is, right there. And so you go up to the G axis and you identify the output associated with it, which means you need to find the associated Y value. And this is the Y value. So G of -2 is +4. Okay, so essentially what you're trying to do, what's the Y value associated with an X value of 2? I'm sorry, -2.
Mhm.
Good so far? Other
Yeah.
than my pen color here?
Hey, it's good color.
I appreciate that. Okay, so we're putting a +4 in here. Now you do the same thing, except you do it with the f function. This is the input now to the f function. The input to the f function. So find 4, and what's the output of the f function for 4?
0?
Whoa.
Oh, wait, just kidding. 2. Is that right?
Well, where are we looking for 4?
Oh, let's see. Okay, I was looking at the G. We're looking for,
Oh, I was looking at the wrong
um,
function too, by the way.
okay. Is it 2?
Yes, so we go to the x spot on 2. So go to wherever
Okay.
x is on the x-axis. Find 4 on the
Okay.
x-axis. Go up to the function, and what's the associated y value? 2. So
Yeah.
the answer is 2.
Okay, that makes sense. Thank you.
Okay. So composition is when it's the Taco Bell function. You're putting something inside of another thing. So the output of the G becomes the input to the F. Questions? Feeling good? All right. Well, good. We'll keep them coming. And candidly, I don't think I did that when I was doing functions originally. When I was doing section 4.3 and combining functions, we didn't, for some reason, we didn't hit that one. So I don't know why, but I'm glad you mentioned it. Sent me the question because it gave me an opportunity to go back and do that. Because that's a good question. That's a good test question, for sure. Okay, let's go back. Where are we at? There we're at.
I just have a quick question about the final exam.
Uh huh.
Will it be like all the other tests we've taken where we don't have to take it during like a class period? We can just take it on our own time throughout the day?
Yeah, probably. Yeah, yeah. Oh, yeah, yeah. I'll set it for probably to open on, what is that, Monday, the 9th, and to close on sometime on Thursday. I'll give you the
Okay.
4-day period, but it has to be done by Thursday. And for those of you who aren't here, it has to be done during that by that Thursday because I have to do final grades and submit them by
Yeah, of
the
course.
following Monday. So
Okay.
uh, less flexibility on that one.
All right, sounds good. Thank you.
Okay. So it's any other questions before we dive back on in? Okay. So yesterday we did inverses. We were looking at polynomials, and we're going to do some division. Oof. Maybe I'll skip division because I got to review that. It's been a long time since I've done division, polynomial division. It's been a while, so I had to kind of review that on my own. So let's finish up the 5.1 at least on the polynomial functions and inequalities. And what we're honing in on a lot of this stuff here when we're dealing with polynomials is we want to find what's called the solutions. Okay, so there's a couple of different ways we've approached it throughout the course of the session. Let me kind of get my pen here. If you remember through the course of things, you've solved equations like this. Whoops, I didn't mean to do that. And we're not going to do this one. This is an example. Okay. So we've solved an equation like this, and what we're doing in this week is, well, we're treating this as a function, okay? F of x is 2x plus 1. And we want to find what's called the zeros, okay? The zeros means basically when does the function equal 0 at its core? That's what when we say what are the zeros, we're saying when does the function equal 0. But also keep in mind that another way of expressing the same thing is we're saying, when is the output of the function 0? Okay? Three different ways of asking the same problem. What are the zeros? When is the function, output of the function equal to 0? Or solve the equation, 2x plus 1 equals 0. They all mean the same thing. Find the value of x that makes the entire thing 0. Okay, it's all the same thing. And what we're drawing back on and where we're going with this uh, is that this. It all connects back to pretty much the fundamental same thing. We want to take a look at the picture, the graph, and when we mean by zeros, what we mean by zeros is where does the graph hit the x-axis? That's what it means to be a zero. That's what it means to be a solution as well. Finding the zero of a function means when is the output 0? When is it an x-intercept? What are the values of the x-intercepts? It's all the same terminology. It's all the same thing. Finding the zeros means find the x-intercepts. Means set it equal to 0 and solve for the variable. So I just wanted to give you that background because we're going to start seeing this. We're going to start seeing zeros, and it's something specific, but it's stuff that you've already seen. Okay, so let's see. Oh, we talked about this one. What's the leading coefficient? Oh, this is sort of interesting. Um, so let me get you. Well, let me do this one. What's going on here? We want to find the degree and the leading coefficient of this function, of this thing right here. And how did we identify the degree and the leading coefficient? How would we determine the degree? What was the rule that we came up with yesterday? Do y'all remember?
The highest exponent?
Highest exponent. Now, that only works when you have all addition or subtraction, okay? 5x plus, x minus, or equals 1 plus, okay? Okay, so all addition or subtraction.
Uh-huh.
We can't use that rule yet because what's going on here? How would you read this? Uh, I'm gonna move places. Oh. Come on, Mom. Okay, had to change scenery, get closer to my Wi-Fi router. Okay, so what we're trying to do is find the degree and the leading coefficient. Now here this reads, and let's read it, negative 5x squared times x minus 7 times x minus 8. So we have multiplication. You can't do that. You
Uh-huh.
can't find the degree yet. You gotta you gotta undo the multiplication. So we have to multiply everything out. We have to multiply everything out. And that's what? FOIL, all that jazz, multiplying things through.
Yeah.
Now, we could go through that exercise. And if we did that here, I would probably say, let's do it. I'm not going to multiply the outside yet. I'm going to multiply the two binomials here. I'm going to apply FOIL to those. So if I apply FOIL to those, I get x squared minus 15x minus plus, sorry, 56. Now I multiply the 5x squared, negative 5x squared inside. So I get negative 5x squared times x squared is negative 5x to the fourth plus 75 x to the third minus 280 x squared. So based upon this thing now, what's the degree?
Four.
4.
Yeah.
And
Said
what's the leading
two.
and then what's the leading coefficient?
Um. Well, 280 or no, because it's negative 75.
So this was the term that determined your degree, right?
Oh, yeah.
So you use
So
the
is that
negative 5. You use the negative 5 in front.
okay?
So the term that gives you the degree is what we call the leading term. And the leading coefficient is the value in front of the variable of that leading term.
Gotcha. Thank you.
Okay, so that's the long way to do this. Just multiply everything out, and that's a surefire way to get it. Let me pause. Any questions on that?
Um.
Any questions on this one? Okay, here's a shortcut. Here's a more direct way of looking. Take this value here and multiply it to every one of the variable values. So negative 5x squared times x times x. What does that give you?
Negative. I'm sorry. Yeah, negative 5x to the fourth again.
And there it is. So we could have seen it straight away on that.
Oh, well, that's cool. Okay.
Yeah.
Thank you.
So let's do another one.
Oh.
So what's the degree on this one? We take the 4x squared,
Also to the fourth?
multiply by the x and the x here, just the x's. When you're dealing with the leading coefficient and the degree, this is all you have to do. So
Yeah.
this gives us 4x to the fourth. So the degree is 4, and the leading coefficient also happens to be 4. Let me throw you another one. Let me throw you a zinger a little bit. It's not a zinger, but h of x equals negative 3x, well, negative 3x to the fifth times 2x squared minus 1, and then times, I don't know what, x plus 3. Okay, so what's the degree and the leading coefficient on this one?
Eight?
Close.
Oh,
Take
shit.
this,
Okay.
multiply this, and
Mhm.
this. So negative 3x to the fifth times 2x squared times x. What's negative 3 times 2?
-6.
And then we add up the exponents.
Right. So it's 5 plus 2
Oh,
is 7 plus 1 is 8.
yeah, you're right. I'm sorry, 8. You said,
Oh,
I
yeah, no
asked you
problem.
degree and you said 8, and I was not thinking right. You're right. It is
No
8.
problem. Cool.
And the leading coefficient is the negative 6.
-6. Okay, cool.
So that's a shortcut way of doing it. Uh,
I like that.
Probably the easier way. Okay, good, good. It says, so here on this one, we're going to do, this one's 4, and this one's 4. Let's see what the next one is. Submit answer. We got it. Thank you. Scoring great. Next. Okay, so this asks us then, what's going on with the graph as we approach negative and positive infinity? So we have to ask ourselves, if we know that the degree is 4, okay, the degree is 4, and the leading coefficient is also, it's positive 4, okay? That's important. What's going on with the graph? What does the base graph look like? This is a with a degree of 4, that means we're dealing with an x to the 4th situation. What's the base graph look like? Y'all remember?
I could be wrong, but since we have, oh, never mind. I was gonna say since we have an x squared, it would be like a U shape, but we
Oh
don't really
no,
have x
that's
squared.
not wrong. Yeah, you're right. This has some more stuff into it. It does have an x squared component, but you look at the leading
Right.
coefficient. The leading coefficient dictates the shape. But x squared, x to the 4th, x to the 6th, 8th, 10th, 12th, whatever, they all follow the same pattern.
Oh,
They're all U's, except this is just a steeper U. A steeper
great.
it's this. Okay? It's a steeper U. It's just if it's squared, it's nice and gentle. If it's 4th, 6th, 8th, 10th, 12th, whatever. As the degree goes up, it gets to be more of a steeper U.
Hmm.
Now, how did I know that it opened up, by the way? Why didn't it open down?
Is positive
What's positive?
the leading coefficient?
Right. Leading coefficient positive opens up. Le- uh, Leading coefficient negative opens down. And more particularly, it gets a little hairy when you're dealing with odd degrees, 1, 5, 1, 3, 5. So x cubed, x to the 5th, and whatnot. So
Hmm.
the way that I do it is positive the sign of the leading coefficient tells you not what your left tail, it tells you what your right tail is doing. It tells you if it's pointing up. In an even degree, 2, 4, 6, 8, 10 degree, that means that the left and the right point in the same direction. In an odd degree polynomial, they point in opposite directions. So, but the leading coefficient tells you what the right is doing, what the right is doing. Okay, and I'll take a look at another one. I'll show you that. So for this particular one, though, this is what we were doing yesterday. As you go left and right, what's going on to the graph as you move this way and as you move this way? So as I move left, what's happening to the y values? The y values are what?
They go up.
They're going up. And where do they go up to? All the way to
Positive
infinity.
infinity.
Mhm. And what about as you go in the right direction towards positive infinity? What's happening to the y's?
They also go up.
Yeah, positive
Positive.
infinity.
Great.
Okay, let me switch it up real quick. Let me do a different one. I'm going to do this. Instead of 4x squared, I'm going to change it to negative 3x. What's the degree? What's the leading coefficient? What's the degree on this one? Take the negative 3 on the outside, multiply with x times x
Cubed.
cubed. Right. So which is a what degree, what number?
3.
A third degree. And leading coefficient?
Negative 3.
Negative 3. So then what's going on with the graph? What's it telling us? What does this information tell us? Well, what's the base shape of the graph, of a cubic graph? It's a snake. What shape do a snake make? A serpentine. Yeah, it can look like that, but this one, yeah, that would probably be accurate on this particular one. So there's two ways you can draw it, and so here the degree of 3 means that the tails point in opposite directions. One's going up, one's going down. Okay, this is true for lines, degree of 1, serpentine with a degree of 3, and so on and so forth. So what's the base if it's a positive? leading coefficient, it looks like this. My finger got in the way. Sorry. It looks like that. If it's a positive leading coefficient. If it's a negative leading coefficient, what happens? Flip it. Flip it. So what does that look like when we flip it? This part comes up here. This part comes down here. And we still go through the 0. The pink line. So as x goes towards negative infinity, what's going on to the function? Traveling up, 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 up. We're going up forever. So that one's going to positive infinity, but as x goes into infinity, what's happening to the output of the function? Down, 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 down. Negative infinity. So the takeaway here is you want to associate the degree and the leading coefficient, and you want to associate it with the graph. What does x squared, x to the 4th, x to the 6th, what does that graph look like? And how does the leading coefficient being positive or negative change it? It'll flip it across the x-axis. All right, questions? Okay. Let's press forward. So skip. What do we got here? Plot the intercepts. Okay. Number of intercepts. Okay. Whew. This is where, by the way, you can use your graphing tool. There's a couple of bits of information you need to be able to do this. I would probably remember a week or so ago, we found that website where you can graph. I would encourage you to use that website again.
Is that Desmos?
Desmos, yes.
Oh.
You can use that graph for this. You type in x squared plus x minus 6. If you didn't have that, you can still do this one by hand. What you need to do is you need to find the x-intercepts. And what does that mean to be an x-intercept? When does this function equal 0? When is the output 0? When does the function equal 0? So we would have to solve this, and you have to go back to, if you were to do this by hand, you would have to go back to your lesson on solving quadratic equations. And you would say, oh, I remember quadratic equations. I can factor this. This is x plus 3 times x minus 2 equals 0. Set each individual factor equal to 0. So we say, well, x plus 3 is 0. X minus 2 is 0. And so now solve, and we get x is negative 3. Oops, mistake. X is negative 3. And then this one here says x is negative 2. Positive 2. How does this help us? We use this to go down to the graph, okay? You're going to plot those points. Those are going to be the x-intercepts. So to find the x-intercept means set the equation, the function, equal to 0. Find the x's that make a 0, and you have to solve using your techniques from prior in the class, solving an equation of sorts. So once you have that, we can't graph yet. There's more information we need, but we got to scroll down. We got to scroll down just a little bit. So we take those two values, what was it, negative 3 and 2? You go to the x-axis, put a dot on negative 3 and positive 2. Put a dot. That tells you where it's going to cross the x-axis. But we don't know how it's going to cross it. Is it going to do this? Is it going to do this? We don't know. We need a third point. We need a third point. And what's that third point going to be? Anybody know? Let me ask it this way. What's the base shape for this function?
And a U going up.
Are you going up? And the
Um,
critical point, what's this critical point right there?
at the 0.
The 0 is where it crosses the x-axis.
Okay.
And we only, so it has to go, it has to drop below that line.
Uh-huh. Oh,
What's that drop below line? What's that point right there called? The lowest point.
technically, I know that looks like a -2, but
Oh,
oh,
I don't know what it is. I just know it
vertex.
has to drop below it. We have to find the vertex
Okay.
of this function. So when you're dealing with quadratics, the turnaround point, either at the top or at the bottom, that's called the vertex. And how do we find the vertex? Y'all remember? Probably not. It's been a couple weeks. The x value, remember you were finding the vertex is an ordered pair, x comma y. The x part of it is found by the formula minus b over 2a. In this function, what is the b value? The b value. And how do we find it? So review. We're preparing for the final already.
Is the B value the X in this one?
That's where you look. So you look for the value in front of the x.
Right. Okay.
And so what is that value?
1.
So we plug in 1 for b. So it gives us -1 because there was a minus sign in front. What's the a value?
1 again in front of the X squared.
In front of the x squared. We look in front of the x squared, and there's a 1 in front of that. So over 2 times 1. And then we'll just simplify that. So the x coordinate of this is 1/2. Oh, it's -1/2. Sorry. So the x coordinate of the vertex is -1/2. Now we need to find the y coordinate that pairs with it. How are we going to do that? This is the input to the function. Plug it in wherever you see an x. Plug in the value -1/2. And that's going to pop out the output, which is the y coordinate. So if we do that here, s of -1/2, and you can do -0.5 if you want. So so this gives us positive 1/4 plus -0.5. I'm going to turn it to decimals because it's easier to work with. What is that? -5 point, nope, 0.25. There it is. So that's what this value is over here. -1/2, -6.25. So we have our 3 points. We have our 3 points. So now we come down here. So we have 2 x-intercepts, one at -3, the other one at 2, and then it says that the vertex is -1/2, -6.25. So try to find that. It's like right there. Oh, let's see. Won't do it. Enable zoom pan, disable zoom pan, 2. Okay, well, maybe it's just wanting us to, let's say, submit it. Okay, so all it wanted us to do was, it says graph. Oh, it says plot all it wanted us to do was plot the x-intercepts. I didn't read it close enough. So all we had to do is just plot the x-intercepts, put dots where the x-intercepts are. My apologies. I went too much.
You
Okay,
might use
questions
that
on this
later.
one? Okay, this one wants us to sketch the graph by identifying where the graph is positive and where the graph is negative. So we know this graph is a U that opens up and it's got to dip down below. In order for it to be a U, that means it's got to come down here, cross the x-axis. So it means it's got to dip down below and then turn back up. Okay? Now where it does it, we actually found the point. We know where it does turn. It actually does this. It actually does this. It comes down, it dips and turns about right here. Looks like that. Goes all the way down there and shoots back up. But because it's a U, we know it has to cross through and come back up. So that's kind of the general shape. So there it is. Oh, that's decrease. So that's the section below. And there we go. Yay, we found it. Okay, let's go to the next. See what we got. Okay, solve the equation by factoring using the quadratic formula. Same thing we've done already. Let's use the quadratic formula. It's been a while. Let's do it again. We haven't seen this in action. What's that quadratic formula? Spit it back out to me. I know you memorized it. Anybody remember?
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a.
Boom. I love the song. Exactly right. Exactly right. So then we need to know what's A, B, and C. You would say A is what? One. Right. What is B? Close. You're in the right neighborhood. -5, right? Always remember the sign in front, and then C, it's the 37. Okay, so now we get to work. So minus B, take the opposite of B, take the opposite of B, so opposite of -5, plus minus. Oh, this is not going to be fun. I'm going to tell you that right now. -5 squared minus 4. A is 1. And then C, sorry, is 37. All of that over 2 times 1. Order of operations. So resolve that. -5 becomes +5. 2 times 1 at the bottom becomes 2. So the work really is inside the square root. So -5 squared is +25. Minus 4 times 1 times 37 is, I have no idea. 148. This is funny. Now we do the subtraction on the inside. The square root of -143. All right, that's what we got. All right, where do we go? We have 5 plus or minus the square root of negative 143, all of that over 2. Ideas.
I think that 143 is supposed to be 123.
So yeah, let me check. 4 times 37. Oh, yeah. You're right. It is supposed to be 123. You're exactly right. Thank you. Always check my math. Thank you. So we have a negative 123 on the inside. Are we done? What would we have to do? What do we get when we have a negative inside of a square root?
And I.
An I.
Hmm.
We pull the negative out and we turn it into an I. The 123, you can't do anything with it other than leave it as square root of 123. That's it. That's it. So let me pause. Any questions on that?
Is that all we have to do? So we don't have to do like set it equal to 0 still, and then I mean I'm really happy because this is it.
Well, it already set us equal to 0 at the beginning.
Right.
Okay.
Okay.
We already had that part. If it says
Yeah.
find the x-intercepts, that's what it means. Set it equal to 0
Okay.
and solve. So
Okay.
essentially what we're doing is we're trying to find the x-intercepts.
Okay. Cool. So this means is there a possible way to set that on a graph?
How would it look on the graph? That's actually where I wanted to go. How would this look on the graph? Does anybody remember? So let's first you'll have to remind me what the answer is. So let's make sure we know what the answer is what uh, a fraction no words keyboard fraction. There we go. So it's 2 down there. 5 plus I square root 123. And then fraction 5 minus square root, oops, I, oh, let's do it again. Let's do this. Fraction 5 minus I square root 123. Submit answer. Okay, good. So Addie raises a great question, and it's where I wanted to go as well. What does this look like on a graph? What's the base shape of this function? Because it's a quadratic, and how do we know? It has a leading exponent of 2. That means it's a U. That means it makes a U shape. But the U could be, there's 3 different ways. You have 2 x-intercepts. It dips down below the x-axis and then comes back up. Or it has 1 x-intercept. It hits the x-axis and comes back up. Or it has no x-intercepts. It doesn't even hit the x-axis. Those are the 3 options. Which one do we have here? Does it hit it twice? Does it hit it once? Or does it hit it no times? Because we got an I, a negative inside that square root, it means it hits it no times. It just comes down and scoops back up. Never even hits the x-axis. This I means there are no x-intercepts, no real x-intercept, no real number x-intercepts. So think of it kind of like a plane trying to land, and then it, whoops, has to go back up and take off. It's the same idea. Questions? So this is going back to stuff, in these polynomial functions, they're going back to stuff you did back in the quadratics. finding the number of x-intercepts, solving quadratic equations, solving equations, finding the x-intercepts. This is really just a refresher on that, and throwing in what's the degree and the leading coefficient. Okay, same sort of idea here. Write the polynomial function in the form of p of x less than 0, greater than 0. What? Let's see what the answer is. I don't understand what they're wanting. Find the zeros, -1 and 6. Okay. Submit. Yes, I am. I am confused. Okay, I guess it just wanted us to find the zeros. Find the zeros. And remember what that means? Find when this thing here equals 0. Find when it equals 0. To find the zeros means when does the function equal 0? So if we take this thing x minus 6, set it equal to 0. Well, what do we have? X squared times x plus 1 times x minus 6. If three numbers multiplied with each other equal 0, what do you know about the numbers? One of them must be 0. So set them all equal to 0. Just like we did with the quadratics. And then solve each of them for 0. So we get this one has to be, that means that x is equal to 0. That means this one is what? X has got to be -1. Solving for x. And then solving for x here, same thing. X has got to be 6. That's how I got the zeros. Questions on that part? It's really just setting each factor equal to 0 and then finding the x that makes it 0. Makes each factor equal to 0. Sorry. Check the chat. I would check that in a while. Whew. Anyway. Okay, so let's see what the second part of this is. So finding the zeros just means take each factor and set it equal to 0. Okay, now test each interval to find the solution. Express your inequality. Test each interval. Oh, now I get it. Okay, so what we're trying to do is let's keep in mind what we got. We found the zeros. So we know one of the zeros is going to hit right here at 0. We know another one's going to hit right here at -1. And we know another one's going to hit right here at 6. Test each interval to find the solution of the polynomial inequality. Okay, so what is the graph going to do? The graph is going to do this. It looks like that. So what values, so this is the value of -1 of x, okay? This is the x of -1. This is the x of 0. And this is the x of 6. Which interval of x's will give you a positive? Okay. In other words, what intervals is our graph situated above the x-axis? So it's above the x-axis in this section right here. It's above the x-axis. So what's that interval up here? What interval? X is less than, oh, so this is how we're going to do it. Take these three. We did this the other day. Now I'm thinking about it. Set them each greater than 0. It's the same thing. Set them each. We did this the other day. I forgot. Greater than 0. Sorry, my handwriting is getting pretty poor here. And solve the intervals. What gives you, so this gives us, this here gives us the inequality, what? X greater than 0, solving for x. This gives us x greater than -1. And this gives us what? X greater than 6. So you write the intervals for each. You write the intervals for each. So what's the interval here? Well, x greater than 0 is what? 0 to infinity. Oh, sorry. So the interval, test each interval. So it's these intervals right here, the ones that I'm circling. Okay. I, I know it's this interval. So it's from negative infinity all the way to -1. Then from -1 to 0 on the x, and then from 0 to 6. Nope, not 0 to 6. 6 to infinity. So how do we do this? How do we do this? What you want to do, let me kind of go back to it. I'll take that down because it's too much clutter at that point. You want to look at the graph. Look at the graph. And the way the graph is going to work is that it's going to come down. It's an x to the fourth. And x to the fourth makes a u, but it also makes a w. It also makes a x to the fourth generally is a w. It's a u or a w. Okay, it can be both. So in this case, it's a w when it has more than one x-intercept, more than one 0. So that's what this one has here. Is it has it comes down. Let me see. Crosses -1. Comes down at 0. I'm trying to do this from memory. I'm sorry. I'll go. What I'll probably do is push forward and come back to this. This can't be right. That's what I'm going to have to do. I'm going to push forward. And I'm going to come back to this one because let's see what they got. Oh, okay. They're just taking the zeros. I see now. They're just taking the zeros and finding the intervals between them. Okay. I'll push forward. Let's skip ahead. The endpoints are not included. How do I know that they're not included? because it's just a plain old greater than. You don't include, you exclude. So we don't include. Good. And so now you write the intervals for each. You write the intervals for each. So I ended up having it right. I just didn't do it right. Okay. Let's go back to practice. Let's push forward. This is, oops. I'm getting bogged down. Okay, so identify the correct graph. This one would probably be good. Use that Desmos graph. Use that Desmos. But here, notice what's the degree of the polynomial here for this function. What's the degree? X times X times X. The degree is 3. And the leading coefficient? 1. So look at the X times minus X. So that's X times minus X, which is minus 1. So that gives us the leading coefficient of -1. So this is a degree of 3, which means that the endpoints point in different directions. But because the leading coefficient is negative, you flip it. So it looks like this. So it's going to look like this. A serpentine where the right tail points down. So that's what we got to look for. A serpentine where the right tail points down. And that, which one fits? Either this one or this one. We just need to know which one it is. Which one is it? And there, the tiebreaker is, what are the zeros? Where is it crossing the x-axis? This one here crosses it at 6, -2, and then +1. So 6, -2, +1. This one here is 6, 2, and 1. Can't be that one. It's got to be this one. So you want to get the general, you want to do the degree and the leading coefficient to get the general shape, and then you use the zeros to identify which of the graphs specifically it is. So just to recap, we found the degree is 3. That let us know we're dealing with a serpentine, an S function. We found the leading coefficient is -1. That tells us the orientation. That means that the right tail points down. This one couldn't be it because the right tail points up, and same thing here. The right tail points up. Can't be it. So we need one that has a right tail that points down, which these two have. So the way that you're going to tell, so which one is it? Well, look at where it crosses. Look at where it crosses the x-axis. Okay? See where it matches up. So this one has a 0 of what? 6. Take the opposite of that 6. This 0 is -2. Take the opposite of that 2. And this one here, when you solve 1 minus x for 0, it becomes 1. So look for where it crosses 6, 2, 6, 1, and 2, -2. That's why this one worked out. This has an x-intercept of 6 and an x-intercept of 1, but this other intercept was +2, not -2. Not -2. That's why it didn't work. We needed this x-intercept to be over here at -2. And it didn't fit. So that's how that one's going to work. Degree, leading coefficient gets you the shape, and you narrow it down by identifying the zeros. And so this is going to be our solution. X-intercepts. Oh, wait, I didn't see. We have to do the x-intercepts too. Okay. Okay, so I'm going to skip it. All right, solve the polynomial equation. So this one here is the factoring. Notice you can pull out a GCF of x and turn it into x squared minus 18x plus 17. Then you can factor the inside. You can factor the inside. And so that gives you x minus 17 times x minus 1. And so what are the zeros? What are the solutions? What's the 0 for this one? So we said it, that becomes 0. How about this one? What's the 0 for this one? When we set x minus 17 equal to 0, what do we get? Well, so remember what we do? Take each factor. Take each
17.
factor. Oops. Yeah, there it is. Take each factor and set it equal to 0 and solve. So this one, well, that is 0. This one here is x is 17. And this one here is what? So those are the values that we put in. So it's just more of the same. Find the zeros. Find the zeros. So let me pause there. When they want you to, in this one, they're dealing with polynomial equations. They're really dealing with quadratics, factoring. You have to refresh your memory on the methodology, either the factoring method or the quadratic formula for solving quadratic equations. Any questions on that? And so what you want to do also is you want to be able to build the graph. What's the graph? And just remember, squares and even degree polynomials, the tails point up. Odd degree polynomials, the tails point in opposite directions. And the leading coefficient being positive or negative tells you what's going on with the right tail. Pointing up, pointing down, things like that. Okay, let me go home. And let's look at that next one. I'm going to skip the division because I got to go refresh my memory. It's been a long time since I've done division. Candidly, I probably haven't done it since high school, which is probably 1993 when I last did this, 1994. So I got to go refresh myself. So this one here, locating. Let me look at that one too, because you know what? There is a process for that. I'll go and look at that one too, because there's a way to do it that requires division. I remember that now. The fundamental theorem of algebra. Let's skip ahead to 5.4. Fundamental theorem of algebra. And let's actually look at the book, because I want to refresh my memory on that one too, real quick. This is the theorem. It says, if P is a polynomial with a degree of n higher than 1, then P has at least one 0. Oh, okay. That is, the equation P of x has at least one solution, right? It's important to note that the 0 of P is consequently the solution. Maybe a non-real, okay, I was about to say. This is not really a fundamental theorem. This is basically, this basically says that every polynomial with a degree higher than 1, so not lines, not linear functions, but quadratics, qubits, fourth power, fifth power, whatever the degree is, has at least one solution. It can be complex. That's all it's saying. This is stuff we're already been doing. Graphing polynomial, we've been doing this already. That's funny. The conjugates. I'm just looking through real quick. Okay, let's exit this. We can actually do this. We've actually, funny enough, we've been doing a lot of this already. Okay, find the degree and the y-intercept. Express the intercept as an ordered pair. So we want to know, what's the degree? First of all, can we find the degree? Can we find the degree? How would we go about doing it? What's different here is normally we would say x times x times x, right? To find the degree. But what's going on is, look, we have exponents on the outside. Okay? So that, remember what the exponents do for us? It just means more of it, more copies. So this is really x to the fifth squared is x to the fifth times x to the fifth. X plus 5 times x plus 5. X minus 1 to the fifth means x minus 1, you need 5 copies. And then tack on the x minus 2. So how many x's do we have? How many x's? 1, 2, 3, 4, 5, 6. Wait, I think I miscounted. 1, 2, 3, 4, 5, 6, 7, 8. So the degree of the polynomial is 8. Do you all see that? Let me pause there. And all we did was we just translated those exponents out. And then you count your x's. So what does it mean then to be a y-intercept? This goes all the way back a couple weeks, a month, maybe even 6 weeks now. How do we find the x-intercept? Let's go back to the xy axis. What does it mean to be a y-intercept, I mean? Any takers? Which, is it the pink point or is it the red point that is the y-intercept? The pink or the red? I see you, Addie. Go for it.
Red.
It
It's
is
where it
red.
crosses the y-axis.
Crosses the y-axis.
Okay.
So what's special? What do we know about that point? Remember, this is an xy ordered pair. Everything's an xy ordered pair. What, do we know either of those values, x or y? When you're on the y-intercept? What are all x's? When you're on the y-intercept, what's the value of x? The value of x is 0. Because it's right here.
Okay.
That's the value of x 0.
Okay. I got you.
So this is asking us, find the y-intercept. So how are we going to do that? Everywhere you see an x, what are you going to plug in? Zeros. When x is 0, that gives you the y-intercept. So what do I get when so essentially it wants us input 0 into the function. Input 0 into the function. And so you get 0 plus 5 squared, 0 minus 1 to the fifth, 0 minus 2. And now you do order of operations. Sorry, I missed that. So 0 plus 5 squared, 0 minus 1 to the fifth, 0 minus 2. So what do y'all get? 0 plus 5 squared is 5 squared plus plus. Oh no, it's times, not plus, times. Times. So this is 5 to the second times negative 1 to the fifth times negative 2. So 5 to the second is 25. What's negative 1 to the fifth? Negative 1 times negative 1 times negative 1 times negative 1 times negative 1, negative 1,
-1.
and then negative 2. And so now we multiply this and we get the value of 50. 25 times negative 1 times negative 2. So let me pause there. Any questions on finding the degree of 8 or the x-intercept of 50? I'm sorry, y-intercept of 50?
I did have a question. So we know that I understand that we plugged in 0 for we plugged in 0 for f of x because 0 was our x value. How did we know, how could we see on the graph that it crossed the y-intercept? You had said that every time we cross the y-axis, the x value for that is 0,
Mm-hmm.
correct? Okay. For this particular problem, though, how did we find that out?
I don't know the shape of this graph. It's an
Oh,
eighth degree polynomial. I think this graph would look like that, something like that.
wow.
I don't know. I'm
Yeah.
imagining it. So the thing about it, a graph can cross the x-axis multiple times. It can only cross the y-axis once. It only have one y-intercept.
Okay.
So it happens to be, something way up here. It'll do its thing. I don't know what it's going to do. But it can only do it once. And the reason for that is because it has to be a function. Well, I mean, I'm not going to belabor the point. But by the graph, I couldn't tell by the graph where it is. But just it's a reminder. This is a reminder. This came out of left field. I'll say it that way. You haven't been asked to find the y-intercept in probably about a month to 6 weeks. And
Yeah.
so that's why I wanted to sort of hone in on it, because it's like, oh, well, look, there's a review question right there. Y-intercept. Was that on our last test? But how far back was that? That was back probably at the beginning of November. Maybe that was way before Halloween. So anywho, I wanted to hone in on it. We've been talking about x-intercepts, solutions, zeros. That's when the function is 0. The output of the function, the y value is 0. Here, it asks you for the y-intercept, and you have to remember, oh, wait, that means that the input is 0. Plug in 0 for x and find the output associated with it. So it's just a refresher on that.
Okay. Thank you.
So here we go. We got another one. So I'll give you this one. What's the degree of this one? Excuse me. 6, right. Yep, there's 5 x's, right. Wonderful. This means that there are 5 x's and one more x to go gives us a degree of 6. Perfect. Perfect. And then, so what is our y-intercept? Input 0 for x. So we get 0 plus 1, 0 minus 2 to the 5th power. So that's 1 times negative 2 to the 5th. Negative 2 to the 5th is, you can do it on your calculator, but it's negative 32, and that's the answer. Cool beans? Okay. Okay, so let's put that one in. 6. And then you have to write it as an ordered pair. What did we just say? Negative 32? Submit. Okay, good. We got it. So let's look at the next part of this. So select the number of x-intercepts at which f crosses the x-axis. So the degree, let me say it this way. Oftentimes the degree tells you how many times it crosses the x-axis. So a degree of 6 tells you it crosses probably 6 times, generally speaking, but not all the time. Not all the time. So here, and it won't do it all the time. When you have an exponent like this, it'll cross less times. This is what we call sort of a root, a repeated root. Has like multiplicity. We'll get to that in a little bit. But the point is on this one, you would expect it because the degree is 6. Because the degree is 6, you would expect it to cross the x-axis 6 times. But if it crosses the x-axis 6 separate times, that means it has 6 separate x-intercepts, okay? But when we look at the function here, there's only 2 that we can see. We remember, the process doesn't change. You set the factors equal to 0, okay? And we're going to set this one equal. Let me move down here. I'll give myself some space. We'll set this one to 0 as well. It crosses the x-axis here at x equals -1 for sure. How do we solve this thing down here for x? How do I get rid of this exponent to the 5th power? Well, you take the inverse, the opposite. So instead of, remember, to undo a square, you do a square root. To undo a cube, you do a cube root. To undo a 5th power, you take the 5th root. Take the 5th root. So we're going to take the 5th root of 0. But what's the 5th root of 0? Goose egg, right. And so that still only leaves us with one distinct value. Instead of 5 distinct values, because the exponent is 5, it's saying they all collapse down and gather at that one value of 2. We call that a repeated root, or that the root has multiplicity, meaning multiple zeros. It's sort of represented multiple times on that one. So instead of 6 separate spots, they collapse down to that one, that 2. So we have 2 distinct places where it crosses the x-axis. And the way that you do it is you just, same way, set those 2 factors equal to 0 and find the values. Just like we've been doing, for the last couple lessons. Let me pause here. Questions on that, on how we find the roots?
Yeah, how would I know that I don't just go ahead and kind of distribute and apply the 5th power to the x and the -2?
So when it wants you to find, so when it wants you to find the x-intercepts,
Okay.
remember that means set it equal to 0. The output is 0. And that
Okay.
means it wants you to solve. Okay? And think back to when we did solving quadratics. We had to factor them because we can't. We had to factor them and use that theorem. If 2 numbers multiply with each other to get the value of 0, then either A or B is 0. The reason we can do that is because of that multiplication symbol right there. So look at this. When we say x plus 1, it reads x plus 1 times x minus 2. 2 numbers are multiplying to give 0. One of them or the other. So that's why you wouldn't want to factor, just relating back to what we did with solving quadratic equations, it's already factored for you. And so one of those factors has got to be 0. Set it equal to 0. So that's kind of, how would you know? It's the fact that it's already factored. You don't want to. You want to resist that. Most of the time, the only time you would really combine and bring it together is if you were to see the phrase simplify. Simplify. That's where you want to foil it all out and kind of repackage it.
Thank you. Yeah, I need to pay more attention in math to what they're actually asking. Because I see something, I'm like, oh, I think I know what I can do here, but I shouldn't, not necessarily that I need to do that right
And
here.
that connects back to something I mentioned at the beginning, and it sort of, it still rings true, but I haven't said it in a while, so my apologies for not setting it up right, is connect the directions with the process.
Yeah.
And so this is a good one here to say the foiling and the combining and the multiplying of polynomials, that's when they want you to simplify most of the time. You'll do that way. Here, when it's talking about x-intercepts and we're in the context of a polynomial, break up, factor. You want to keep it separate.
Okay.
So that's my. I've been forgetting to. I remember I was doing that a lot in the first part of it, but I hadn't to do it. So here we only have 2 distinct x-intercepts. One of them is it well -1 comma 0, and then the other one is 2 comma 0. Those were the 2 ordered pairs. Okay. So then what's next? So that's one thing. They want us to find the number of x-intercepts. Okay, select the number of zeros at which f flattens out. What does it, I don't know what this means. I've never heard this before. What does it mean for f to flatten out? Sounds like a tutor time for us. Tutor time. So let's see.
Horizontal.
Multiplicity. This is what I was talking about earlier. Okay, so we're just using different terminology. The graph actually flattens out by using the geographic meaning of multiplicity. Remember I said that this one here, 5 of those roots are all collapsed on that -2. That's, as we say, that has a multiplicity. It's representing 5 roots all in that one. So what happens to the graph? Now I understand what they mean by flatten out, because what they're describing is what's going on with the graph. So the graph, this is what it will look like. So let's get our XY axis. So what the graph is going to do, which is sort of interesting, it's going to come down. It's going to, kind of, I mean, it's sort of interesting. It'll come down here, turn back up, and it'll flatten out. It'll flatten out at that 2. Let me, but it's going to be sort of a, it's going to be sort of a big flat. It's like a big old flat pancake. It's going to go a long way here and then come down. And where it flattens out at, is that value of 2. It goes flattens out and then drops again. That's what's going on in the graph. So the longer the flattening, the higher the multiplicity. So you could have a long flat like that, which is a pretty high multiplicity, or you could have just a little flat, or even just a, smaller than that. So that's what they're talking about, is when it flattens out, it's really approaching, it's kind of gliding into that 2. So our 2 in this case, our 2, the value, the x-intercept of 2, this is where the 2 would be. It's sort of approach landing, flattening out, and then once it crosses it, it's gonna slide right back down. That's what it means. And that happens when there's a multiplicity, and the multiplicity happens when you have, a multiplicity happens when you have this exponent over the parentheses. So exponent of 3, 2, 4, whatever it is, this one happened to be an exponent of 5. So let's see. Uh, the number of zeros at which it flattens out. So how many of these roots, how many of these parentheses has an exponent over it? Just one. Just the one. So that's the only one that it will flatten out on. Which one does it flatten out? It's this zero right there. And remember that zero was 2 comma 0. Okay. Ooh-wee. I have to look this one up again. This is the thing that I was talking about earlier that I need to refresh my memory because there's a whole methodology. So I got some learning to do over the weekend. This is probably a good point to stop. What do you think? Okay. So I'm going to give you back 7 minutes and let you start your Thanksgiving 7 minutes early. Or you can keep doing work, whatever you want to do. But
Thanks.
I'll go ahead and stop here because I got some learning to do, and I'm going to butcher it and not going to do well, and that would be an injustice to you. So we'll stop here. I'll hang for questions, but if you want to go, feel free to go. Let me know if you do have questions over the weekend. I'll check in as well. And but if we don't talk to each other, hope you have a good Thanksgiving and a restful weekend.
Thank you.
All
Yeah,
right.
have a great Thanksgiving.
Okay. All right. I'll hang back for a few moments if anybody has any questions, but if not, feel free to jet out.
Okay. I don't think I have any specific ones, but I'm going to tutoring, so thank you
Okay.
so much.
There you go. There you go. Hope you feel better, Addie. I hear your cough.
Thank you.
Yeah, that time of year.
'Tis the season to be sneezing.
Oh yeah. Oh, that's a good one. I hadn't heard that before. I'm going to use that.
You sent me a message and I did get it, and I'm going to do all the extra work and take the test this in the next few days because I have 4 days with no kids.
Oh, well, there you go. That's a
So I saved my work. I'm not even gonna lie. I didn't do any of it because I was like, I get to the whole next 4 days with no kids, no interruptions, no anything. So I'm gonna take the test and I'm gonna do all the other stuff.
okay.
And then, yeah. I just wanted to
Well, good.
let you know that that's why I hadn't done anything. And then I was late because I got a new iPad and I had to re-log into everything.
Oh,
Everything.
oh yeah.
Yeah.
It didn't transfer over for you.
It transferred most of my stuff, but I got the new iPad Pro and it's massive.